In this video, we are going to study regarding the detailing of beams as per SP 34 1987, that is a handbook on concrete reinforcement and detailing. So let us start with this. So this is the handbook on concrete reinforcement and detailing. The code number is SP 34 1987. If you see the contents of this code book, so they have given the detailings of foundations, columns, beams, floor slabs, stairs, and other special structures. And they have given regarding bar bending schedules also, but we will be concentrating on beams in today's video. So let us start with the detailing of beams, which is being given in section number 8. So in this, if you see, they have given first is regarding the arrangement of bars. Section number, what you can say, 8.1, that is arrangement of bars. So you'll be seeing one by one. So the regarding the arrangement of bars, first let us see. So the following points has to be noted down while doing the detailing. So first one is that the bars shall be symmetrically placed about the vertical center line of beams. So what it says, if you see, this is a beam in which we have placed two bars at the bottom. The next, the bars which are being placed, it has to be symmetrical about the vertical axis. So for example, if I am going to draw one vertical axis here, so the bars which are being placed, they has to be symmetric about that vertical center line of the beam. So it should not happen that bars are placed only on one side. Next is when there are only two bars in a row, these bars shall be placed at the outer edges. That means, for example, in this case, if you see, we have only two bars. So what has to be done is these bars has to be placed on the outer edges of the beam. It should not be placed in the center. So it has to be placed on the outer edges of the beam. Then next is when the bars of different diameters are placed in a single bottom row, the larger diameter bars are to be placed on the outer side. So what it indicates now, for example, we will take this beam, so wherein we have different diameter of bars. So for example, these outer bars are of 16 mm dia and these inner bars are of 12 mm dia. So when we are having different diameters of bars, so larger diameter of the bars, they have to be placed on the outer edges, and smaller diameter of the bars, they have to be placed on in the inside. So that is what it indicates. Then next is when the bars in a horizontal rows have different diameters, the larger diameter bars shall be placed in a bottom row. So now what it indicates, so for example, now we are placing the bars in two layers. This is one layer and this is another layer. So when we have different diameters of bars, then larger diameter bars have to be placed at bottom and smaller diameter bars have to be placed above that larger diameter bars. This is another one point which we should note down while detailing the beams. Then next we'll come to the longitudinal reinforcement. These bars, what we are seeing regarding this, we'll try to see in these clauses. First one is minimum distance between individual bars. So what should be the distance between these two bars? So that is what they have given. The horizontal distance between two parallel bars shall be usually not less than the following. So the horizontal distance between these two bars or these bars which have been shown here in these figures, so it should not be less than the following. First one is the diameter of the bar if diameters are equal. So for example, if you see this figure, so here all the four bars, they are of same diameter. The spacing between the so individual bar, for example, if you take this bar, if you take this bar and this bar, the spacing between these two bars, it shall not be less than the diameter of the bar if diameters are equal. So for example, if diameters are unequal, like in this case, if the diameters are unequal, the minimum horizontal spacing between these shall not be less than the larger diameter of the bar. That is another thing. Then next is third one is 5 mm more than the nominal maximum size of the aggregate. That is, the spacing between these shall not be less than the nominal maximum size of the coarse aggregate. So that is what they have given in this figure also. If you see this figure carefully, so here they have shown the lines and here they have written that is minimum horizontal spacing. It shall be, it shall not be less than the 5, that is diameter of the bar, or nominal maximum size of the aggregate, that is HA, plus 5 times the diameter of the bar. So here they have given star mark, that means whichever is greater. Star mark they have given, that means here at the bottom they have given whichever is greater. So these conditions has to be satisfied. Then next is similarly, if you see, this was regarding the horizontal spacing of bars. Next, when it comes to the vertical spacing of the bars. So in this case, if you see the vertical spacing of the bars, when the bars are being placed in two layers, the spacing between these two, it has to be either 15 mm or 2/3 of HA, that is nothing but nominal maximum size of the aggregate, or phi, that is nothing but the diameter of the bar, and they have given star mark, that means whichever is greater. So out of this whichever is greater, so that much has to be the minimum vertical spacing between these two bars. Similarly, they have given figure, in this figure they have shown larger diameter bars and smaller diameter bars, and then next is they have shown the bars in different layers. So minimum spacing also they have given horizontal spacing, as well as they have given the minimum vertical spacing. You can see the dotted lines here, minimum vertical spacing between the bars. These are the criteria which has to be satisfied, and minimum horizontal spacing between the bars which has to be satisfied. Then next we'll see some other clauses. So they, as you know, like tension reinforcement, we have some minimum reinforcement criteria, that is 0.85 BD divided by F of Y. The next is we have criteria regarding the maximum reinforcement, that is it should not exceed 0.04 B into D. So in that detail we are not going to go. The next we'll move ahead. The next they have another criteria, that is regarding the side face reinforcement. So when the depth of the web in a beam exceeds 750 mm, then side face reinforcement shall be provided along the two faces. So what it indicates, so if you see now, this is the web of the beam. If the depth of this, if it is going to exceed, so if the depth of this, if it is going to exceed 750 mm, then we have to provide the side face reinforcement. So here in this case now, what is the side face reinforcement? So if you see now, so here they have shown two bars. Here they have shown two bars. These are nothing but the side face reinforcement. If the depth exceeds 750 mm, additional these bars have to be provided. The total area of such reinforcement shall not be less than 0.1 percentage of the web area and shall be distributed equally on two faces. So what bars we are going to provide, its area shall not be less than 0.1 percentage of this web area, as well as it has to be distributed equally on both the faces. On two faces, if you see, they are equally distributed, and area of this shall not be less than 0.1 percentage of the web area. Then next, another thing what they have given here, the spacing regarding what you can see these bars. Here you can see the spacing between this bottom bar, top bar, and this side face reinforcement. So it should not be greater than B. B is nothing but the width of the beam, or 300 mm, whichever is least. So out of this, whichever is least, so that should be the spacing between this side face reinforcement. Then next, they have given regarding the detailing of shear reinforcement. A stirrup in a reinforced concrete beam shall pass around or be otherwise adequately secured to the outermost tension and compression reinforcement, and it should have both its end anchored properly in any one of the fashioned detail which is shown in figure 8.5. So these are figure 8.5. So whenever we are going to provide a bend, so in this way the detailing has to be done. So you can see here it shall be 8 times the diameter of the bar, it shall be 8 times the diameter of the bar, and you can see the line diagram when we are going to provide the bend, 90 degrees bend. So when we are going to provide 135 degrees, then in this way the detailing has to be done. Or some other like we have different ways of anchoring ends of the stirrups. So in this way this has to be followed. Then next there are many, like when you provide multi-legged and all, there are many things. If you want to study in detail you can refer this code book. Then next I'll go to the typical arrangement of beams when we are going to provide the bent up bars and vertical stirrups in a continuous beam. So when we are going to provide bent up bars, so this detailing has to be followed. So this is nothing but one continuous beam wherein we have one end support we have, the next one is intermediate support we have. So if you see at the bottom we have the main reinforcement, out of that few bars they will be taken to the top which is bent up near the supports, which is bent up near the supports, either end supports or intermediate supports. So this can be provided, usually it is provided at 45 degrees or 60 degrees. Then next is if you see the so if you see here they have given these bars are at same level. Then next when you cut the section, this is the section which is visible to us. Then next we will go to the other detailing part. Then next when you have what all different requirements we have for a beam. So if you see this beam, there are many things which have been given here. So first let us see regarding the tension steel, that means the bottom reinforcement what we are going to provide. So there are certain criteria, that is minimum and maximum reinforcement. So minimum is it should not be less than 0.85 times of BD divided by F of Y, and it should not be greater than 0.04 times of B of BD. So this is regarding the tension steel. Then next comes to the stop steel, that is when it is designed for compression reinforcement, it should not be greater than zero point zero 0.04 times of B into D. Then next is regarding this stirrups. The if you see the maximum spacing of stirrups, what we have, the maximum spacing of the stirrups, it should not be greater than 0.75 times of D, or it should not be greater than 450 mm, or it should not be greater than ASV into F of I divided by zero point 0.4 of B. So where ASV is nothing but the area of stirrups legs. The next another thing what they have given is, so the stirrups what we are going to provide from the face of the wall or from the face of the column, the spacing of that stirrup, it should not be greater than the 50 mm. So whenever we are going to tie this first stirrup, the spacing between what you can see this wall surface and the first stirrup, it should not be greater than the 50 mm. Then next is when we cut the section here AA, so you can see the section A which is being given here. So they have given the detailing, that is cover to this stirrup, cover to the stirrup, it should not be less than 50 mm, 15 mm. So you can see here the stirrups which the cover which is being provided, it should not be less than 15 mm. Then next is the cover to the main steel, so that has to be equal to minimum 25 mm or one diameter of the bar 5, whichever is greater, whichever is greater. That means minimum we have to provide 25 mm or the one diameter of the bar, that is larger diameter of the bar. This is the detailing when we have bent up steel. The next is if we are going to do the curtailment of the reinforcement. Then next regarding what you can say the continuous beam and cantilever beam, which is given in the below figures. So this detailing what I am going to tell, it is applicable in the case of continuous beam when the spans are approximately equal, which do not differ by more than 15 percentage of the longest. So note also they have given the same thing. This is applicable when the span they are not differing more than the 15%. In this way the detailing of the bars has to be done. That is curtailment, simplified curtailment rules for the continuous beams. So if you see, this is the end support we have, this is the intermediate support we have. Then next is we have a span, that is effective span L1. So next span is L2. Then next is at the bottom, if you see, they have provided the main reinforcement here at the center, if you see, which is 100%. So when you go to the near to the support, that is, and in the bottom, that is tension reinforcement, so we can provide 30 percentage of the reinforcement. At the center it will be 100 percentage, at near the supports, so we can provide 30 percentage. So from this you can see it is zero point 0.1 times of L1, where L1 is nothing but the effective span. So from the center of this support to the what you can say the curtailment, what we can do, the distance is zero point 0.1 times of L1. So when you go to the intermediate support, so from the center of the support to this curtail reinforcement, so you can have 0.15 times of L1. So up to that you can do the cut, after that you can do the curtailment. Similarly, when you go to the intermediate support, which is on right side, it has to be 0.15 times of L2, where L2 is nothing but the second span. Then next is when you go to the top reinforcement at the support, we have to provide the 100 percentage of the reinforcement. Then next we can go on reducing the reinforcement. So if you see at the support, it is 100 percentage. Then next is we can provide up to 60 percentage, that is up to 0.25 times of L1. So the distance which is from the face of this support to the curtailed bar, the spacing will be, the length will be 0.25 times of L1. The next is up to a distance of 0.15 times of L1, we have to provide the 100 percentage of reinforcement. Up to a distance of 0.25 times of L1, we can provide 60 percentage of reinforcement. So after this line, we can provide the 20 percentage of the reinforcement. Similarly, same thing we'll be having at the intermediate supports. So if you see the left side of support as well as the right side of the support, so from the face of this support you can see up to a distance of 0.15 times of L1 we have to provide 100 percentage of reinforcement. From up to what you can say 0.25 times of L1 we have to we can provide 60 percentage of reinforcement. So beyond this we can provide the 20 percentage of the reinforcement. Similarly on the right side also we can do same thing is that we have to take care regarding this span will be L2, which is this second span. So this is regarding the curtailment rule for the continuous beams. So overall if you see, so what you can remember is that, so at what distance you can curtail 0.25 times of L1 at the top supports. At the bottom we can have zero point 0.1 times of L1. So that is the end support, and 0.15 times of L1 near the intermediate supports. Then next is when you have a simply supported beam, this is the detailing what we can have. So at the center we can have 100 percentage of reinforcement. So near the support we can have 50 percentage of reinforcement. So from the face of the support to that curtail bar, so we can have a distance of 0.08 L. So after this means beyond this we have to do the curtailment. Similarly on the right side also, and a minimum 2 bars have to be provided at the top. Then next is when we'll see the detailing of cantilever beam which is projecting from a column. So you can see this is the column. So from the column, if the cantilever beam is being projected, so how the detailing has to be done. So if you see uh, at the top, we are going to have the main reinforcement, that is AST. So it has to be provided, that is it's the distance up to which 100% reinforcement has to be provided. It should not be less than, greater of these two following, that is zero point 0.5 times of L, where L is nothing but this span we have, or LD, which is nothing but the development length what we have from this phase till this phase. So out of this, greater of these two things, and not less than, what you can say, greater of these two things. So up to this much distance we have to provide the total 100 percentage of reinforcement. After this we can do the curtailment of the bars, that is, but not less than zero point 0.5 half of the AST, that is 50 percentage reinforcement has to be continued beyond this distance. And the stirrups what we are going to tie, so the first stirrup, that spacing should not be greater than 50 mm, and the bottom reinforcement we can provide 25 percentage of the total area of steel, that is minimum steel, subjected to minimum of 2 bar if it is not designed as a doubly reinforced beam. So this is the case when the cantilever beam is projecting from a column. If the cantilever beam, if it is projecting from a beam, then we can do the detailing somewhat in this way. It is almost similar itself, that is AST 100 percentage of the steel, it has to be it has to be provided up to a distance that is greater of zero point 0.5 times of L, where L is nothing but the span as well as the development length, LD. Then next, the bars have to be, so previously only we had a column and a beam, so but here in this case the cantilever beam, it is projecting from a beam. So therefore the bars have to be required, bars should have the required anchorage value on both the sides. So similar to this point, 25 percentage of the minimum EST, that is minimum 2 bars we have to provide, and 50 percentage of reinforcement we can have beyond this line. This is the case when we have cantilever beam which is projecting from a beam. Then next is so these are the points what we have. So if you want to study it in detail, you can refer this code book SP34.